Okay, we're working some of your practice problems from your 12.5 homework, and we're picking up with number 11 in this video. So go ahead and take a minute. Let's read the problem. Assume the hold time of callers to a cable company is normally distributed, which that's always kind of the preface of the problem. It has to fit in the normal curve way, but many things do. Can be normalized. So as long as it says it's following a normal distribution or a normal curve, we could use this z-score method. And it tells us our mean. That's the kind of stuff we had to find in the last section, is calculate our mean and our standard deviation, but those are typically given in this section just to save time. So determine the percent of callers who are on hold between 4.6 and 5.8 minutes. Now you'll notice, let's see, 4.6 and 5.8 are numbers that are not included in this chart. They're too big. They don't fit in this. This only goes to negative 3.4 and positive 3.4. So something's up there, right? These aren't the actual numbers that we'll use on the z-table. We always have to convert, if it's given in mean and standard deviation form, we have to convert that to a z-score. So we need our little z-score formula, which you'll have, I know, in your notes, but I'm going to remind you, the z-score formula says you always take the mean minus the standard deviation, the number minus the mean divided by the standard deviation. So let me put that in words. Z equals your piece of data, that's the x value, whatever, you know, like 4.6 and 5.8. Those are the numbers we're going to work with. The piece of data minus the mean, which is given in these problems, 4.8, and then divide it by the standard deviation. That's how we use that formula, and it converts it just perfectly for this chart. So the piece of data, we'll start with 4.6. We'll have to do both of these. Subtract the mean, which was given as 4.8, over the standard deviation of 0.6. So we go to our calculator, type that in, 4.6 minus 4.8 equals, and then divide that by 0.6, you'll get negative 0.3 repeating. Okay. Now we take that as a z-score. That's now converted to a z-score, and we can use our table of values. So we can do that now, or we can wait until we get both of our z-scores, and that's sort of up to you. I think I'll hang on to that for a minute. That's one of my z-scores. And remember, if we're doing a between problem, like we are here, between, we subtract the two answers once we get our z-score values. Okay, then I look up, do the 5.8. 5.8 minus the mean of 4.8 divided by the standard deviation of 0.6. Let's get that z-score. Let's see, 5.8 minus 4.8 is 1. I should have known that, right? And then divide that by 0.6, and I get 1.6 repeating. Okay, now I have my two z-scores, and it's basically, we're back to what we did on number 9 and 10, just right before that. What did we do when we had two z-scores and we had to find between? We went to the chart, we found those two answers and subtracted. Between is always subtract. So let's see, negative 0.3, that's down here, negative 0.33, that's 0, 1, 2, 3, is 0.3, let's see. What is that? 0.3707. That's this z-score on the table. Now I've got to look at positive 1.666 repeating. The chart only uses 3 values though, so I'm going to have to round that to 1.67 to use my chart correctly. Alright, so let's look on the positive side of my chart. Look up 1.6, and then I need to go over to 7. The rounding didn't affect the last one, but here it rounded up because it was 6 repeating, so that would make a little difference in your answer, so do be cautious about that. I see 0.9525. Alright, so that's my value. I'm going to put that on top of this because it's bigger, and I need to subtract those. Okay, so let's subtract those two z values, 0.9525 minus 0.37307 is 0.5818. Shoo, that was a lot of steps, right? And notice it wants this as a percent. So finally, we have to move these two places to make that percent form. So that'll be 58.18 for the final answer. Shoo-wee, right? That's a lot of steps. Maybe we'll be doing that again because I think we could stand a repeat of that. And here we go. Now that's 10. Let's see, I need to do 12 next, right? That was number 11. I have all these extra pages I should not have printed. All right, number 12. It is similar, I believe. Let's see. No, it's a straight below question. So it's actually a little easier than the last one. When we do a below question, that's like a less than question, that corresponds with the chart as is, because the chart gives us the left of a z-value. So it's a little easier when we're doing a less than or a below problem. Okay, so let's see. Let's read our problem, right? Assume that the mathematics scores on this SAT are normally distributed with a mean of 500. Okay, so that means we've got a normal curve. The mean where z equals 0 is at 500. That's the average score on the SAT. And a standard deviation is 100. So standard deviation 100. What percent of the students who took the test have a score below 560? So 560 is somewhere over here above the mean. So they want to know what percent would be below. It's more than 50, right? So you can kind of know your answer if you're way off base. It should be, it looks like, you know, the bulk of the students would get a 560 or below, because that's quite a bit above the mean. So I'm expecting, you know, maybe 80–90%, something pretty large. To find out exactly, I have to convert to a z-score. Remember, to do a z-score, you take the piece of data, which is our 560, is our question we've been asked to solve. 560 minus the mean divided by the standard deviation. Again, those are nicely given to us to help us out. So we type that on our calculator. 60 divided by 100 basically is 0.6. And luckily I don't have to do two problems this time. There's just one question below 560. So I'll look up z as 0.6. This is the negative side of the table, so I've got to flip. 0.60, just regular 0.6 is 0.7257. And that is basically our answer here. We don't have to do as many steps. What did I say? 57. Okay, so then because it is in percent form though, I do need to go to right to get the form that they want. So I was a little off. I thought it would be more percentage than that, but 72.57, that's still, you know, a pretty good amount of it. It's definitely over the 50, like I said, but I was a little off on my estimation, wasn't I? All right, that's number 12. Number 13, we get to do a between question. So over and over, we keep converting these z-scores. If we have, these are raw data, you know, we don't already have them in the z-score format to use this table. So we have to take the mean and the standard deviation. This is basically the same question, only we're doing a between. What percent of students scored between a 580, that's pretty high above the mean, 580 to 650. So that's going to be a very select group of students that had between 580 and 650. I wouldn't expect very many students scored exactly there, but we'll see. I was a little off last time. So both of these, 580 and 650, need to be converted to z-scores. Remember, z equals the piece of data minus the mean and divided by the standard deviation. Again, both given in the problem. So I do that for each of these. 650, let's go ahead and just write that down now, minus 500 over 100. Convert each one of those pieces of data to a z-score. The first one gives me a 0.8. The second one is 1.5. Notice whenever you use the z-score formula, you're always able then to use this chart. You get values that show up on the chart. Both of these are positive values, so I'm going to need to flip this piece of paper over and use the positive value chart. 0.8 is right here, 0.7881. Let's see, I have 0.8 and 1.5. Sorry, my memory is short. I have to keep looking back. You guys already knew that, didn't you? 0.9332. So I get my two values, the 0.8 value and the 1.5 value off of my chart. And then remember, when you do a between question, between is always subtract. So we're subtracting these. 0.9332 minus 0.7881 gives me 0.1451. This is asked as a percent, as most of the last questions are. After we get used to the table, we see it makes more sense to see it in its percent form. Move to right to think of it as 14.51% of the students. That's still more than I thought. I thought it'd be even a slimmer little select group, but 14.51% of the students scored between 580 and 650 on their SAT. Okay, I hope that's helping. I hope you're getting the swing of this. It's kind of repetitive. We keep using these same formulas over and over in different applications. A vending machine is designed to dispense a mean of 7.3 ounces of coffee into an 8-ounce cup. Now, don't let the 8 mess you up. It's just telling you what size the cup is. You really don't use that number in your problem, I don't think, here. If the standard deviation of the amount of coffee dispensed, we need that. That's our standard deviation. And the amount is normally distributed. It has to say that before we can use our little curve idea. And it applies to this Z-table. Find the percent of times the machine will dispense less than 7.36 ounces. So it's designed to dispense average of 7.3 ounces. So your cup, I guess, isn't too full and messy. So the mean is at 7.3. That's your Z equals 0 down the 0 middle of the curve. So if we're going to get a 7.36, we're going to be a little tiny, just a little tiny bit above that. You know, that's 7.30, so 7.36 is a little bit more. And then it says dispense less than. Less than is to the left. How many times is it dispensed from here on back? Less than 7.36. Less than is always our easier questions because that's just how our chart is designed. It gives us the area to the left, which is the less than of. Okay, so what are we looking at? 7.36 is our piece of data. We have to subtract the mean, which is given at 7.3, divided by standard deviation of 0.3. So we always have to convert to our Z-score with this formula over and over. I didn't press it in right, I guess. 7.36 minus 7.3 divided by 0.3 is 0.2. So that's our Z value. Remember, the first side of the chart has negative values. The next part is positive, so I'm looking at 0.20, regular 0.2. That first number is 0.5793. Notice while we're here that Z equals 0, which we're not far from, is 0.5 or 50%, because that's right down the center. The average is dividing it in half, 50-50. But we're a little bit above the mean, like we looked at the at earlier. So a little bit above it. So 57.93 as a percent will be our answer. 57.93 cups of coffee will be less than 7.36. Okay, do we have another one? Oh, they keep on coming, don't they? It looks like I still have quite a few. Let's see. No, maybe 15. I don't know how much more time I have on this video is what I was looking. Maybe we can get one more of these in. But they're kind of all the same from here. I don't think I have anything really new to tell you because they're all sort of like this. Okay, let's see. Just normally distributed, it's mentioned, mean of 46, standard deviation of 6. The details that must be in there to use this. Oh, this one, we won't even have to think as hard. If you think about this, what percent of cars are traveling faster than 46? 46 just so happens to be the mean. So that's Z equals 0. Right down the center, that's where the mean is. So if you're kind of following what I'm saying about this, if you're picking up what I'm putting down here, you know that that's exactly at 50%. That is Z equals 0. We can go through the process and say convert it. You take the number we're asked to find minus the mean divided by the standard deviation, but you'll have 0 over 6. So that's at Z equals 0. When you look for Z equals 0, it's 0.500, as we should expect, to be 50%. So 50% of the data should be above 46% and 50% should be below 46, right? That's what the meaning is here.